we want to make some discussions with you. You may hopefully have some questions as well. So to crack the ice, I will start with one question, but then we can take your questions also. So the first question I want to open discussion will be that from your perspectives, of course, do you think there's a current balance of theoretical and application aspects in the quantum technologies? Because from what we have listened today, there is, of course, quantum technologies with a lot of promises, but it seems there's also need for fundamental research as well. But theoretical fundamental research can have sufficient chance among all these big promises that quantum technologies can offer. I want to hear your opinions on this, maybe.
You are the experimentalist. Yeah. Can you hear me? Okay.
Yeah. Gerd.
So I guess I didn't understand the question.
The question is, there is theoretical research can have sufficient chance to be publishable with respect to all the application promises of because there is, from what we understand from your talks, fundamental questions are still important. And
then I did understand your question, but then it's a question to the series.
The question is to all of you. I mean, if who will be the first, it is up to you.
So if I speak by myself, okay, so I think, well, first of all, I come from a very hardcore theory, I mean, quantum field theory, and then started to do very abstract things, and then I started to suffer from experimentalist, okay? And then I learned that, I mean, one has to do theory that can be implemented, okay? Otherwise, it's useless, okay? So, and I learned when I go to an experimentalist and he says, that's impossible, then I don't follow. And I think this is the good idea. I mean, doing theory that can be feasible and implemented in the lab. And I think in the last years, we are things that some years ago were completely unthinkable. Now you can really think that they can be done in the lab, okay? And from that point of view, some years ago, the crosstalk was small, and now it's more and more intense from my perspective.
Right. My main concern is that there is this high impact journals that you try to be on the cover with nice experimental figures, etc. As a theoretician, usually this is an unfair game. That is what I feel. Yes, please.
You just mentioned high impact.
Yes.
I don't like this hype about high impact, and many of us don't. And I don't really understand, because in principle we can change it. This high impact is I think it's a hype that comes from people who want a simple measure to tell about the quality of research. But the quality of research is not so simple. It's a little bit like people. I mean, can you say person A is better than person B? No, because there's so many different talents, and you can say in this aspect, maybe this person can do better than in another aspect this. And it's the same with research. So it's so multidimensional that it's not really possible to say this paper is 10 times as good as this one. But some people who do evaluation and who maybe, because it's a lot of work to read the paper and judge yourself, and maybe it's not so easy to judge yourself because you don't have you don't know the field so well, and you don't have the background. But in a way, I think this impact factor is the worst of all possible measures. Because, I mean, you go to any of these high impact factor journals, then if you judge the publication by impact factor, it means every single publication in this journal must be of high quality. But then some of them, I mean, on average, of course, this journal is cited higher. This is why it has an impact factor. It says something about the journal, of course. But nevertheless, even in original nature. Occasionally there are papers who never get any citation. Still, it has a high impact factor. And so this I don't like, and I would really like to do something about it. And I think as a community, we can in principle do something about it. It means that in hiring committees, we should really look at the research that people do, that we judge, and not look at the impact factor of their papers. And if the impact factor doesn't play a role anymore, also young people will not want to publish in high impact factor journals, but rather do good research. So this is why I'm not so happy with publication system as it is now. And when you follow what's going on in the publication world, my feeling is the number of different journals is increasing in an exponential way. And we were talking today about exponential is really hard. I mean, in computer science, if the time goes exponentially, so you cannot do. And in principle, anything that grows exponentially is, there will be a clash at some point. It will not work. So my own feeling is that in a way, in science, in research, new research is created. Other researchers consume this. So there's a market, and there are some companies benefiting from this. But it's not the normal market. Normally, I have a car producer like Ferrari builds nice cars, but the people who use Ferrari never build Ferrari. They just use it. Whereas in the scientific world, we are both the producer and the driver. We write our papers that will be judged, but the papers will be judged by our peers. Next month, maybe I am on the other side and judge the paper of this other guy who judged my paper earlier. And so in the end, with all this exponential growth, I think what my wish would be to reduce all this and go back to maybe publishing only with learned societies, partly also because if they then make some revenue from publishing, then this will go back to the members eventually. They can reduce fees for publication or for journals, and then the members will profit. So I'm really unhappy about the publication system as it is now, as you can tell, and I wished one could do something. So this was my general comment.
Sure. Thank you.
I also have a more specific comment, but maybe I've been already talking too long, and maybe you want to talk first.
Okay, so right. When I got my PhD, so I'm a theorist, no, right? So I got my PhD.
That's okay.
Thank you. No. Hinging to that, I went to my brother. He's a musician, right? And
it's also okay.
It's also okay. And he looked at me and he said, "Okay, very well done. Can you fix my car?" I said, "No, I can't." She said, "Wasted time." Right? So why? Right? So I think it's the same.
But you
tension, no?
But you could just do something similar to your brother.
I should. I should, but I'm not that such a bad person. So I think that the tension is the same. So the experimental work will always be something, say, in your face, striking, right? So it's something that you can touch and see immediately.
You can show it, yes.
And therefore, much more prone to, or better prone to raise impact in an immediate manner, in a more immediate manner than theoretical work. Look at the boson sampling paper, the initial boson sampling paper, right? So Osipov and Aronson published in a computer science journal, right? No one cared until the experiment was done, right? So until people realized, okay, I can do it, right? So I can implement it. And then all of a sudden, a paper that was lurking in the back of the community, all of a sudden started raising interest. The same with, for those that know what I'm talking about, with quantum discord. right? So the paper by Zurek and Olivier, or say Vedral, Anderson and Vedral, two very nice papers, fully theoretical. They were there, no one cares. You look at the citation that these two papers got for the first 10 years, something like that, nearly close to zero. Then all of a sudden, the experimental use of Disco to calculate the trace of a matrix comes up, and everyone is in Disco. Then this paper starts getting, raising impact, generating impact. So it's natural, right? So it's immediate to raise more impact the moment you realize something. But it's also true what Gerd said. We have so many avenues now to publish that really I think that question shouldn't be, how much is the impact factor of the journal, or should I publish in this journal because it has a higher impact factor than the other. This might be good for your, I don't know, for your first job application and your fellowship application, and it makes, of course, great if you have a Nature paper or two and or more. I wish I had more Nature papers than what I have. But the question should be really, would a piece of research have an impact in 10 years, be still cited, say, in 10 years? Because if that is the case, then I think you can forget about what is the impact factor of the bloody journal where you published. Having said that, again, as a theorist, I am the editor of an IOP journal, and I ask for more experimental papers in the journals, because I think there are too many theoretical papers published in the journal. So it really depends on what you are looking at. Yes, we have avenues to publish fully theoretical paper. How much impact we generate? Well, that depends on the value of the research that is reported, and also on a bit of vision, I think.
Right. But Mauro, what you said is a bit. You have the feeling it's a bit negative that this suggestion of boson sampling was sleeping for a while, or others. You could also say EPR. EPR was for 20 years, 30 years was. But now everybody knows about the EPR paper from 1935.
Of course.
Although it was not cited in the first 15 years.
Of course.
Only by a few people who are well known, of course.
Sure.
So in hindsight. But from an experimental point of view, I think, gee whiz, there are all these theory papers, some that you mentioned. They really started a field. Maybe they were so much ahead of their time that it took a while to catch on, but they were really the pioneers. So I really admire them. And for me, this is extremely positive.
It's not a negative comment.
Yeah,
It's not a negative comment.
What
I wanted to stress is that sometimes a really valuable theoretical contribution somehow gets unnoticed until there is the spark of the experiment that somehow validates.
Yeah, I agree.
Okay, sure.
But maybe
not said in a
maybe this is quite natural, because it could be that if other theorists say, "Oh, yes, I can describe something in terms of characterize something in terms of discord, and they have done it, but I can do it too." And there's no. But then, if you apply it to different experiments, then it opens up more. Then also more theorists become interested in, because the experimentalists tell them, well, in the platform where I realize this, I have these additional problems. So this initial model did not take this into account. Can you help me do this? And then this, so this is quite a natural.
It was not meant to be a negative comment at all.
On the other hand, we can also look at the problem from the journal's point of view, especially in a field like quantum technology. It is a very new field, and new journals are trying to come into play. And there are also very established journals already, Nature, Science, FRL, and so on. So for these new journals, some of them are trying to produce some review articles to increase their impact, perhaps. And we also have similar problems here. We have actually a very nice Turkish Journal of Physics that we also encourage some review articles for new fields actually to get in attraction. I don't think this is a too bad thing to do, especially for this new field. Some overview and review articles are useful, but some journals may be overdoing this. I would like to also maybe take your suggestions. If you're a new journal, if you think that quantum metrology is not well represented, and if you start as a new journal as your life, what is the ethical and also the efficient way of doing that according to your experience?
I'm sitting in the middle of some interference. I think it must be between the loudspeaker because and also hear you directly. So it's, although I'm closest to you, could you hear him well? Maybe it's just dispositioned. Maybe I go over there.
Sure. So, yeah.
Maybe you can hear better here. Permute.
Go ahead.
With the journals, you mean? Well, of course, there is a whole machinery to boost the impact parameter of the journals. And professionals, they know how to do that, okay? And they try how to do that. That's okay. But in the end, okay, I tend to agree with Gerd that in the long term, I think journals from learned societies are the more reliable sources. Okay, I mean you started a journal on quantum metrology, right?
Well, Matteo Paris.
Yeah, okay, but you were also under, yeah, and there was no way to, because it was the Guiter, right?
Yeah.
And I mean, now the topic is everywhere.
Yeah.
But because of the Guiter, I mean, who knew about the Guiter some years ago? Okay. And there was no possibility. And now you have all these journals like NDPI, which are almost predatory journals, okay, because they offer publish or perish for almost nothing. You have also some of this advanced quantum stuff that, I mean, they can get a good impact factor, but I have the impression that with no very fair, tricky things, okay? In the end, I agree. I mean, you go to APS, Optica, IOP, and these are the journals that in the long term will survive. I think this is the impression.
Also, the old journals divide after the discovery of new topics. Physical review divided into many journals now, PRR and others.
You have a very quick way of making a journal popular. Offer waivers, right? So you start making people offering waivers to pay charges, and people will send articles to it. The point is not. I don't think that the important bit should be boosting the journal, is to make it sustainable.
Exactly, I agree. Yeah.
So many of the new journals are in quantum. I don't think are very sustainable, and I don't think have a very robust strategy to be out there for a long time. You see, so every year I get this, again, so because I'm an editor of this journal in IOP, the publisher sends me the data, okay, on the citations and number of papers published by journal X, Y, and Z. So what they call the competitors, okay? And you see that there are journals that do great the first 2 years, then all of a sudden, bang. Not only the impact factor, not only that, but really the volume of submissions to the journal drops quite significantly. And I think it's because they simply don't have a sustainable strategy for the journal. They don't have the vision that possibly a structure like a learned society behind the journal itself can provide. The sort of sustainable route to lasting that these more profit-oriented avenues have.
They are not business-oriented in the end. Profit, of course, in the long term should be, but it's not the main goal, okay? Sure.
So a few weeks ago, I had someone from a publishing company wanted a chat, wanted to chat with me because they wanted to have an opinion on whether or not they had to launch. So it was a good idea to launch a journal on quantum machine learning. He said, "You are crazy. I mean, we are 15 in publishing in the area. So you do it, you are going to get 15 very good papers, and then after that,
That's it.
that's it."
Yes.
And needless to say, it was not what he wanted to hear. So he was very disappointed. Really, so you think it's not a good idea? No, it's not a good idea. But that's the attitude.
Yeah, yeah. At least they try to build a good editorial board. This is also important for reputation, a good start, especially. Yeah, definitely. So we can also, of course, wish we are talking, and if we will keep talking, we love to talk each other. But please feel free to interrupt and ask questions anytime you like.
Oh, I had a comment to the initial statement by Lewis, who said, if I understood correctly, that initially he has been working on very fundamental things, but
No, I said hardcore. Okay.
hardcore, and then basically there's some benefit in working closer with experimentalists. I think you need all of this, of course. In order to make some breakthrough, you have to think independent of boundary conditions in some way that you just have some inspiration and go. And how this will fit, and this is true for both on the experimental and the theoretical side, I think. So on the theory side, you can do some hardcore, which seemingly doesn't have any applications, but eventually, when you look at this theory work that is now done close with experiments, if you look back 50, 100 years, maybe at some point it was some hardcore which didn't have some connection. And then the experimental side, there of course is also development of technology, which at that level, deep down in the experimental lab, there's not much link to theory, but at some point you have better measurement tools, better sensors, better devices, and then suddenly also theorists now become interested because it comes closer to when it would be useful to test their theories. So I think on both these sides, all this is needed. I would not discard any of this.
No. Actually, I mean, at the beginning, I was trying to write things elegantly. Now I try to write things that can be understood by and this is thanks to my experimentalist friends.
Yeah. Okay. Then the next question. Also, I'm asking maybe too much from theoretical perspective, but sometimes we write a very mathematical theoretical paper, and it's also accepted in a high impact good journal. And then the editor asks, we are going to publish it, but please also send us a one-page public summary, video abstract and graphical abstract to make your idea more less technical and make it more public. Is a journal, do you think, should have such a mission to make the, because it is very difficult for many universities compared to Western universities, maybe in Turkey, we don't have that experience or strong media support, etc. And sometimes it's a pain both for the student and the researcher to make a public summary of a mathematical abstract paper. I understand that especially for quantum technologies, this can be very important because it's very abstract and need to be publicized. But do you think should journals be following such a public summaries, video abstracts? Is it a good thing or is it not that critical? Or basically, science communication at the public level, should it be a job for a technical journal or?
No. I mean, I think again that so young people when trying to publish, okay, they look especially to impact factor, okay, and well, it's going back to the same problem as before. I mean, this impact factor is just something that can be used as a tool, but nothing more. I mean, in the end, good papers are always in APS, IOP, Optica, or something like that, okay? And so I try to avoid as much as possible all these extra things, okay, for my students. This is my impression.
Yeah.
IOP, I'm becoming more and more.
This is usually optional, but it becomes, after a certain while, it becomes a must because you compete and make your research more public. Of course, this public summary is also addressing the technical people because you can get a more quick idea about the journal, I think.
Well, Mauro was saying that, of course, in the editorial office, you get we have a meeting every month, and they send us, they send me the potential competitors, okay? Every month, the list is increased by 1 or 2, okay? But, and they, I mean, in the editorial office, okay, they get nervous because they want to have all this, impact factor. But in the long term, I'm completely confident that the list will be, asymptotically convergent to the list we all know. This is my impression. Of course.
So one of the real big.
Stay here hiding somewhere. Yes, please. Why not? Please join us. So let's also get a. Yeah, welcome. Okay. Yeah, please. So welcome. He just arrived from the airport. Welcome. So yeah. Okay, sorry to interrupt. We were discussing.
So one of the real big breakthroughs about 10 years ago was the detection of gravitational waves. Leuchs mentioned it today. And they could have published this anywhere, of course.
Yes.
Every journal would have loved to take it. You know where they published. And they did this on purpose. So they published in a well-known journal of a learned society in first draft letters. So I think APS was happy about this, but they did it for a good reason.
Yeah. You have something.
But then you have unforeseen problems, okay? Because APS, like Optica, of course, the leading journal is PRL. But now impact factor of PRL is low because PRX quantum, PRX is and they are facing a problem with that. It's like Optis letters and Optis express the same, or Optica. I mean, yes, please.
I think on that note, even when I was a PhD student, we still had the culture of publishing in, for example, PRL. You get the main message out there in a concise way, and then you publish a separate PRA or PRB, depending on your topic, PRC, and then you delve deeper, you explain. Now there's something called supplementary information, which is usually 30, 40 pages, which is exactly what that's supposed to be. But those are good reference, reviewed, long details, which we're kind of missing now because the supplementary is still there, technically, the information is still there, but it's not really reviewed. So if there's a problem there, a graduate student is trying to reproduce the results, you lose that continuity.
Nobody pays attention when preparing the supplemental material. I mean, you don't care at all. I mean, I don't care. And before, I mean, you even submitted simultaneously the letter, because in the old terms, in the old times, okay, the PRL letters were letters to the editor. I mean, dear editor, I wish to draw your attention to the fact that, and just now this supplemental material, I hate that.
Okay. Then another question is about, especially we are doing some interdisciplinary research in quantum technologies, and together with Mauro and also with my friends here, there's now big teams in biology, medicine, quantum. They all come together and then they come up with a paper. Then finding a referee for such a paper should be also a big problem for an editor. And then do you think for this modern interdisciplinary approaches on these topics, you need to consult a lot of referees, or how to make the refereeing process fast and efficient for such interdisciplinary papers?
yeah, it's getting difficult to find referees anyway.
Oh yes.
So even for say not necessarily that interdisciplinary research. Okay. Post-COVID, people have become a lot more protective of their own time. So very often you get the reply, sorry, I have other commits. And I'd rather focus on something else. And so this is a proviso. Okay, fine. No, let's agree on that. Finding good reviews is something complicated. If on top of that you are the extra degree of complexity of interdisciplinarity, yeah, it becomes a difficult job altogether. So what makes it worse is that most of the journals, at least those I'm aware of, rely on databases rather than picking up, say, ad hoc, the best choice in many cases, the best choice of reviewer. And the database is built on data taken from Scopus.
That's right.
So it's nearly algorithmic. No intent to form the
Advertising.
you know what I mean. And I don't think that helps in terms of securing good quality reviews at all. I think this is so. Your question is part of a broader discussion, a broader point on are we sure that the current model that we are implementing for peer review is the best model that we have? Some journals have run this community-led open discussion policy that also is really the quality of the paper is basically decided upon open, publicly available discussion on a given journal or a given paper. Do I like it? I'm not sure. Do I like the current model? So the established, the editor picks up 2 reviewers, and reviewer 2 is always the bad guy that kills my. I'm not sure. I'm not sure either. But it's a complicated. The problem is that the number of journals has grown proportionally more than the size of the community itself.
Absolutely.
I would say. So it's getting really, really tough to find reviewers altogether, I think.
And especially in some topics. I mean, for example, we are receiving, 90% of the papers in quantum communication, QKD. And if you really in the technology of QKD, you want to have a good reviewer. There are few of them, and they don't, say, look, I sent recently, like 2 days ago, I said, this is the 3rd paper you sent to me this month. Because, the topic is very typical, and the guy is the expert. And of course, there are some other experts that they don't work properly. They said, no, I'm overburdened. I don't review anymore. So it's difficult.
One solution maybe some journals are taking is giving credit to referees like PNAS, some not blind but very explicit refereeing processes. Do you favor of this kind of strategies or?
Doesn't work. My experience is that it doesn't work because your time is probably the most precious thing that you have beside your kids, right? Is probably the most precious thing that you have in your hands, and you really want to ring-fence it.
Sure. Sorry.
I think on this, because publishing is treated now in this era, treated more quantitatively. How many papers you publish, what is the impact factor, how many top-level Q1 type publications you have, that determines your career, that determines grants you will get, so you can do more research, that determines the PhD students you can have, that you can attract. So the quantitative element of publishing meant that research for us now has been reduced a bit to doing the research and writing about it, but not reading or contributing to the community. Whereas if you go back 20, 30 years, even, not, you don't have to go that far, reviewing someone's manuscript was part of your research because you were learning something new. It's the same thing, actually, as going to a seminar, going to a conference, right? You listen to other people's works, but you listen because it's part of your research. In the pressure to publish in number, in quantity, means that you're giving up from something. And this becomes, it makes it look like we're too busy, when actually we're giving up research.
And in a way, we were already talking about this before you came. In a way, it's in our hands as more senior researchers. We could decide we don't care about impact factor, bibliometric data. We read the paper, interview the person, ask questions about the paper, and then things will be maybe different in the future. So it's in a way it's a certain laziness also. But
absolutely, this is we need to ask the question to ourselves as community.
So who is the first doing the proper things?
With the what?
Who is the first doing the proper things?
Yeah, exactly. And also, there's no one type of scientific publishing, right? Scientific journalism. There is society-led publication, which is not for profit. It is for us to share. And then there is, of course, the for-profit organizations, Nature, Science, and others, just to name. But there are many more, right? Those are different. And I can go to my society's publication principles, and I can judge them. But I cannot go to a private entity's publication principles and say, you shouldn't be doing this. You should walk the higher moral ground. No, they're there to make profit, and they're there to make profit from your science and your research in a way that is sustainable from their perspective. It's a business model. So we're all part of a business model as opposed to a society that shares. So we have to then say, what do we need to do as scientists so that they find it profitable, maybe less profitable, but still profitable and sustainable, but in a way that benefits us rather than us being effectively employees for them to continue to go forward.
So you're also in favor of publishing in journals of learned societies?
Yes.
Perfect. Very good.
So and what the example you gave, the gravitational wave, what we do in a very, very smaller projection of that, if the work we have is about a known, expected, anticipated result, multiple groups are fighting for it, but it's not a new science, it is achievement, reporting of a progress, then we tend to go for the other more visible journals if possible, so that more people can see it. But if it is a true science one, if it's a true physics one, we demonstrate for the first time that something like this exists, then we tend to go to PRL. PRL is as physicists for me, is our whole. That's our main whole.
Very good.
Yeah. So what are your thoughts about generative AI? Because of some editors actually announced that they are going to use generative AI to get opinions about desk rejections and how to spot, for instance, plagiarism, how to spot different kinds of new science or different overlaps with other works. So what are your thoughts on the uses and the disadvantages of AI in publishing?
Touchy subject.
Well, in principle, any submission we have an automatic checking of plagiarism and use of AI. So, in principle, I think we have tools to detect. Okay, so, and of course, what you say, especially for referees, you are not entitled to use AI. The only thing you can do is just use AI if you are not a native speaker and you want to improve a bit your English, okay? But I think, one should be very careful about the use of AI in journals, yes.
So with these AI checking, you find in no time easily if something has been written this way somewhere else. So if this is about copying from someone else's work, that's of course nobody shall do this, so it's good that this can be found out. But what I struggled a bit is that maybe I do research in a particular field and I publish several papers with some more or less incremental results, improved results. And so this usually happens. You improve your apparatus. Then in the old days, I think we were easily in the introduction to set the stage. We use similar phrases because this is quite natural to lead to the topic. And then came the new result. Nowadays, this is kind of a bit forbidden, right? And it's called self-plagiarism. I cannot use the same words again that I used before. So this I feel is a bit strange. You too?
It is, yeah, it is, absolutely.
Our nation's Science Foundation has a policy, I think 3 pages of policy on using AI, generative AI for refereeing and publications and so on. I think they allow for using it for some literature review, etc. But you have to explicitly mention that you have used AI in this document. And for refereeing, it is completely forbidden. This is that kind of policy.
But it is coming, right? So it has arrived. There are many scientists out there using AI without declaring it. And it'll just be a matter of people who adopt it in the right way, or institutions that adopt it in a healthy way, so that it's actually honest, it's fair, and it's for the benefit of the people using it. Any tool can be used for both good and bad, of course. So you have to make sure that you're not prohibiting it to the point where it's used still, but quietly, secretly, behind closed doors, but it's openly used for common good. And it's like the start of the computers means that you can now compute as opposed to analytically solve, right? There's that benefit. That didn't make us less of physicists or scientists, but we had to change the way we do it. With AI, we have to change whether we like it or not. Things have to change. I would not be surprised if journals go to AI to review. To AI to review?
Yes, of course.
Yeah, of course.
Or even even if it's not full-blown review, they might go for some sifting. Is this sensible? Is this not sensible? What the editor does in those some of those journals. So it is coming whether we like it or not, and that's a bit of a problem. So we have to make sure that it's steered, the policy on how to use it is steered in the right way.
Okay.
So yesterday I was talking to some of the groups here and also the students, and they asked me about AI and is it how. Then we were looking back, and there was also at some point our laptops. We got laptops, but even before, I remember the time when suddenly pocket calculators were achievable for normal people. When they first came, they were so expensive that many people couldn't. But then at some point, and now they are very cheap. But I remember the discussion saying when children in school use this, they lose the ability to calculate themselves. And that was a big discussion. But I don't think it really was important in hindsight. So as Mete, I think this using AI, so many people started this, not everybody, but many people, and you cannot stop this. My hope is that AI will never be able to do real breakthroughs, papers that will open a new field, because AI is trained by what has been published before. AI can probably do. So if someone wants to come up with a paper completely fake doing with the AI, it could be done probably in the way, you remember this, what was his name? Hendrik Schön, I think, but he faked experiments. But of course he faked it in a way because there was some expectation. If only someone could do these experiments, this should come out. And so from a theory side, there was expectation. And that I think AI could do, because this expectation is out there. So if you ask AI, can you help me fake something? They could, but real big progress in the sense that there's some result that will be an inspiration to the field and open new things. I'm not sure AI can do this, but who knows?
In a different way, okay? So what Mathematica did for theory. I mean, we don't expect that Mathematica can do anything new, but however, you can use Mathematica to help you in doing new things, okay? So it's a tool that right now everyone has to use.
Where I see AI directly impacting research productivity beyond better writing or solving equations for you or something, is finding out, which is something we do quite a lot in science, finding similarities in a mathematical formalism in one field and realizing that it's applicable in another field. We won't be able to do it because we don't have the time to go and learn about hearing to understand that that's Poisson distribution signals, and then from then on understand that this is very similar to homodynamics.
Because of our finite bandwidth.
Finite bandwidth, exactly. AI goes in there and says, same equation. It figures out that it's the same equation. So there will be some, and especially in topics like complexity, emergence, quantum condensed matter physics, there is a lot of these kind of relations that people find and say, even in the case of string theory being applicable to condensed matter phenomena, AI will be able to pull those out. So in that sense, it will take our jobs away from us to a certain extent. But you're also right that it won't necessarily have the motivation, perhaps, to come up with something new. The goal of AI, I don't think, is to be able to come up with something new. And I also know that in Google, for example, there's a strong team working on hallucination. There is a problem. The problem is even when you turn off hallucination. So if you go to advanced mode in these things, you can opt to turn off hallucination completely. So you say, whatever you tell me, do not hallucinate. Give me only things you know, only things that are real, and it still hallucinates. So it's not really well controlled. Right? So there's that element in there as well, and maybe that's okay for the creativity part. But it's we have to be careful what it takes.
It wants to dream. Well, another, so we discussed modern things, but let's go back a little bit, at least my personal history. I have learned a lot quantum optics from science conference proceedings, but this proceeding tradition seems to me dying or getting less popular in quantum technologies, especially. But I remember these lectures like Les Horge and etc. You can learn a lot. They were like very nice lecture notes, etc. But do we have such a thing for quantum technologies that some good proceedings, or we should just rely on special issues in journals?
Well, I think right now, I mean, you have all these special issues in all these journals, okay, that I don't think proceedings make sense anymore.
There is even a journal called Journal of Physics Conferences.
Yeah, it's IOP, of course. So with 1,000 volumes a year, okay, because I mean, and also now Springer has the same, okay, Springer proceedings. I don't know. Okay?
So there is still some
But it's a community-dependent thing. I mean, computer scientists value proceedings much more than what.
Oh yeah, sure.
And so
Publication secondary.
Proceeding
extreme. So I was head of department till a couple of years ago. So I had to go to faculty meetings where I had the head of computer science in my faculty, and you had to address applications for promotion or progression. Right. And then you had the tension between the physicist submitting all these 4 pages papers. What are they? I mean, 4 pages, right? So cannot be serious. That was the comment, right? So a 4-page paper cannot be something really serious. It has to be 40 something, and that's the mathematician. And then all the computer scientists that were looking for, where is the conference paper? Where is the conference paper? And then the tough part of the job was to convince them, we don't take conference papers as seriously as you do. Okay? For them, it's a lot more important. Much more important than a journal publication.
I think IEEE has a very nice proceedings also for quantum. Okay, so I am cracking the ice, but any questions from audience? No? Too much pressure? Then maybe do you feel any problems from experimentalists we started from discussion from the point of view of theoreticians, but maybe from your side as an experimental.
Yeah, indeed, from an experimentalist point of view, what do you think will be the biggest few breakthroughs that are coming in the next few years in quantum communication, sensing, or materials, devices, or computing?
You mean some new breakthrough?
New breakthroughs.
If it's new, nobody can tell you now. Otherwise, it would not be new.
Yeah, it's difficult.
So what you can expect, the answer to this question is by definition more incremental. What you really want to look for.
There are, when you look at ACS Nano or some journals, they had their editors come together and they published unsolved questions in nanoscience and nanotechnology type of publications. So I was curious about your thoughts about unsolved questions in quantum physics and quantum science.
There is, some 2 years ago, Pavel Horodecki and Karol Sikowski and Łukasz Rudnicki, they published 5 potential problems in quantum information science, okay? But I don't think they are, for example, for a theory, there is this problem of what the number of mutually unbased bases in dimension 6, okay? Okay, this is a fantastic problem, but I don't think it's a breakthrough, okay? So these problems they are quite interesting for a theorist, but it's difficult to see if in the long term they are really a breakthrough.
But then when this is done eventually, and if one finds something, it is not so new because the problem is discussed. It's only, so in this sense, I would say, of course, you could say this is a breakthrough, but it's not completely novel because the discussion is out there.
And also depends, this problem of dimension 6, so it requires, very sophisticated mathematics. So to some point I was interested in the problem. And then I was talking to a famous professor in Galois fields, okay, it's Niederreiter, and he told me, look, the problem is difficult but completely uninteresting. So I'm not interested in cooperating with you, okay? So it's difficult to say what is a breakthrough, okay?
Well, maybe you can also mention that there are now experiments thanks to access to quantum computers. People publish some codes run in a Qiskit in quantum computer as like an experimental paper. So some theoreticians also write that kind of papers. But reproduction of them or evaluation of them is also quite tricky, I can imagine, for a referee. So it's not actually a theory paper, but sent to a theoretician usually. But when I also receive a lot of such papers, but I don't have time to run a code in Qiskit. It gives me waiting time, etc. So do you think this kind of papers should be sent to some really physics journals as an experimental paper, or do you think they should be categorized under a different study? Because the results are very difficult to reproduce and their experimental value is not a real experiment as far as I can imagine. Yeah, if you leave me all the questions to me, I will continue to ask strange questions if you... Yes.
Just a quick answer or maybe comment on that. When you review a paper, you don't actually go into the lab and reproduce the result. That's not what actually is asked of you, right? You're looking at, you're doing a sanity check. Does it make sense? Do the equations follow? Is there any error in the equations? But you don't actually go and try to simulate.
My point
There's a sense of trust there.
My point is this is different than a physical setup. And still everything is inside the computer, and its interpretation is not as easy from a physical point of view, from my point of view. But if it's like an optical of experiments, from my experience, I can produce some kind of intuition. But to judge the result of a quantum computer, it is a little bit less tricky. Okay, so
I'm not physicist. I have no idea about all the formula that you showed, but it looks like quantum has a great potential to be used in many different technology. You talk about always potential. I mean, what is the bottleneck really in the field that is not being transferred, commonly being used, all those different technology that you have discussed today. I mean, what needs to be done in terms of research or in terms of translation of basic science into a technology that many different technology can benefit from it, basically. Anyone, can answer that question. The way that a molecular biologist can understand basic.
I think if you look at the semiconductor technology, the way it has grown, it really started with silicon, and then no one even doubted it. There's a period of time when people started to, they were brave enough to suggest something else, gallium arsenide, and it kind of disappeared, and it's always silicon, right? And now, of course, we're adding, there's always different variations of it, but there's a concept of a foundry type standard, we agree, and then you improve on top of that, keeping to the principles of so if you come up with something a bit better but completely offline from the what a foundry can do, large scale, you don't even propose it anymore. You publish it in an obscure journal and you move on, right? Whereas quantum is not like that, because we haven't yet pinned down the hardware, we haven't pinned down the algorithm, we haven't pinned down the question we want to solve. Peter Shor has a great suggestion, but why are there no, we should, by this time, we should have a long list of algorithms that we think are going to work superior. We have a few, and the latest Google results is an example of this, but it's always task specific. So we haven't yet, first of all, we're not working on that single track where everyone joins forces. We're still, in a way, friendly, competing with each other, with hardware and also with algorithms. That's a plus and of course a negative. It slows down progress because we're not working together, even in competition. But it also creates very surprising scenarios where the first, say, quantum advantage publication used superconducting qubits. Today, the best quantum computer is Rydberg atom arrays. And you wouldn't know back then, a few years ago, 2019. In 2019, you would not have said Rydberg atoms. So that keeps the field very rich, but also unpredictable. That's why we keep having to say potential. I don't think we know what the right qubit in the end is going to be 10 years from now.
Right. Even more fundamentally, we don't even know what quantum computation will be able to do that really significantly, say, better than classical one. So it's a key that needs to prove himself for herself. Okay, so there is a lot of potential with some exceptions. I think that QKE and to some extent certain version of sensing are much more grounded, much better proven in terms of advantages and really true potential than more striking but less explored, less clear areas like computation. So I know that, this morning we said we started looking into that since 1980, so it's already quite a bit, but it's too early. It's just too early.
Well, there are two time scales, right? Or two milestones, let's say. The first milestone is when you really demonstrate that a particular quantum technology has an advantage over classical counterpart. For quantum computing, this has been done by many physical systems. Communication, this has been done on the security side. Sensing, there are some sensors out there, clocks, timing, all this. But then there's another time scale, which is usefulness. So if you think about it, where quantum beats classical is the first break-even point. And then there's a second one where it doesn't beat it. There are many technologies out there, conventional technologies, that has beaten the previous established technology, and it didn't matter because the cost to replace it is too high and the gain is not that significant, so that just dies off and then off it goes, right? So in the same spirit, there is one more milestone that is useful. We have to get to a point where it needs to be properly useful before it will be adopted.
In that respect, if I can add, there is one aspect that nearly no one is looking at, which is really the energetic cost of this technology. So are we entirely sure that in the end we can afford the bill? And I think people have started looking into aspects of it, but it might end up that despite the theoretical capabilities of a full-fledged quantum computer, you need to pay a lot of bucks, and then you really don't want to or cannot afford it. I mean, you rather warm up your house rather than no. And so there are features that we are not necessarily looking at this stage that might determine whether or not it's useful in a pragmatic sense, and that we should start looking at.
Yeah, there is also this quantum energy initiative, right? People seriously discuss the energetic costs in the community of these technologies and organizing meetings and conferences about this issue. Yeah. Well,
Then try putting down 11,000 wires down a dilution fridge because you have 1,000 qubits. 1,000 qubits will solve a lot of problems. It will be powerful enough to solve a lot of problems. Your problem will not be your qubits. We'll probably get to the qubits. It's the 11,000 wires that need to go down and keep the sample still at 4 millikelvin. That will be limited.
at least for this kind of architecture. So then you need to find another style. This Mauro is working on some neuromorphic applications which are energetically more promising and so on.
But
Every challenge in physics is like a new puzzle, yes. So
I'll add one thing that is more positive, let's say, because there are a lot of challenges. The positive thing is this. The two milestones that I mentioned, if you get to, no one cares until you get to the first milestone. You don't have eyes on you. You get to the first milestone, then it's exciting. The second milestone, the real one, that's going to be the proper, relevant for proper industry. In between, it looks like you're stalling. So even though you've improved from the break-even point by a factor 2 or 3 or 4, it will always look like you're stalling. So there's an element of, why aren't they delivering right now? Well, because they're getting better and better, but it takes time to get to the second milestone. You weren't looking at the process and the progression until we got to the first milestone. Now you're looking too carefully. Don't give us time to build it up. That's up to the boy.
if there's any questions, no.
Okay, hello. This is a general question about actually, I think, research, not maybe only for quantum technologies, but you're talking about journals. And do you have, and I think you mentioned a little bit about your ideas about this, but I think that the science journal publishing is the verge of a collapse because you mentioned a lot of things. It's not working very properly, and with all this impact factors and things like that, we have to think of new ways. Do you have any ideas about these? Because I know universities are talking about this a lot, that they're not going to take into account quantitative measures for academic performance. But this is on the university side, and I don't know much about what has been spoken on the side of journals. Are they considering any innovative measures? This is my first question, and also I'm curious about this. Are there any? So still the reviewers know who the writers are, right? On this, no? Is it blinded?
You can be double blind.
I also wanna learn your opinions about this. Do you?
There's blind and double blind, and triple blind doesn't exist, right?
Double blind. Yeah, you can be double blind.
Yeah, it's half blind is, I think, general thing, but the double blind. What do you think about these practices? This one.
So I think you're right. The fact that there's this hype about the impact factor tells us it's useful because there are many people who don't want to spend so much time on reading the papers in detail and making a judgment yourself, which would be the best way. But then, as we said, impact factor is probably not the best of the many possibilities. And you are asking, is there anything else? So we've been thinking about this, and I think one possibility is that you make use of what is already happening. So there's one time when each manuscript is looked at in detail. This is when you submit it to the journal. So the editor looks at it, and then it's looked at in detail by 1 or 2 or 3 referees. And if one could make use of this judgment, which is more in-depth, I mean, this is all subjective, but this will always be like this. But I think this would be much better. Then the question would be, how can you turn this into a general measure? So we discussed this in Optica, and then the board of editors, they said, but we have already editor's pick. So there are some based on the editing process, refereeing process. Editors think that a number of papers have particular value, future impact. But the problem is that this is not normalized over many different journals. And so then when you think of, then I was thinking, okay, you could use the impact factor. So the impact factor tells you what's the average citation that all the manuscripts in this journal get. And so it probably means that in a journal with a high impact factor, a fewer percentage of the papers will have very little citations after 5 years or something. So what one could do is use the impact factor to tell a given journal, you can choose like the top 20% of your papers, the top 30%. And then journal with a much lower impact factor is only allowed to give this special mark to 5%. So, but then of course it's getting a bit involved, and the editors didn't like this. But I would, if one wants to do something, this is the only thing I could come up with to try to have a mark which is normalized across different journals. And again, as we were saying before, I think it would be easier to do this just with journals of learned societies. And this is one of the reasons why I was, and others also, speaking in favor of using more learned societies, journals of learned societies.
Mauro, can add some.
Can I chip in?
Yes.
I don't think that the problem is the model. So there is nothing, I don't think that there will be anything that will be better than peer review. That's the standard. The problem is the obsession that we are developing for metric-based assessment. And that's a signature of lack of time. So the moment you don't have the time, the width, the bandwidth to assess really something, you base your opinion on a number. And this is impact factor or H index, okay, number of citations. So the moment universities, but the moment universities start, so I'm talking as a former head of department on my hat on, start basing the assessment criteria on how many millions did you raise as grants, as research funding, how many papers did you publish, how many papers did you publish each year, right? Then the community, to survive, in order to survive, it's natural, is basically forced to move to a metric-oriented assessment. And this is the moment when impact factors and H index and volume of your grants become important. So I personally don't think that there will be a better model than the peer review, blind, double blind. It's variation on a theme. Okay. What should be counted is the obsession for metrics. Now, in fact, I mean, we have evidences that the communities are resilient, say, to perversions given by large impact factors, large number of publications by any given researchers, because they either isolate these sort of trends, or they develop self-healing mechanisms like the San Francisco Declaration. No, so now there are universities that countersign this declaration, where they say, look, in assessing progression or in hiring people at university, we won't look at metric factors like impact and total number of citations. Okay, stuff like that. Then, of course, we are humans. So assessment committee will look into how many papers did he publish last year. Okay, but there are ways to protect the communities from those degenerations, in a sense. But the peer review process, I don't think, my own opinion, so completely ignorable, I don't think there is any need to improve it. Well, it has to be implemented in the right way, but which is the tough part.
Yeah, I mean, but in the mathematics community, they assume that 1 year peer review is okay because you need to do this in the proper way. But then your journal or my journal, okay, they recall that after 2 weeks you need to report.
That's not the journal not the mathematics.
Exactly. So this is.
I mean, it's a community. It's a community.
But I think that this community is getting, I mean, yes, attacked by this.
That's exactly
2 weeks. 2 weeks.
That's exactly what I mean. Is the obsession for being quick, being good in a quantitative, measurable.
But these quantities, they don't commute.
No, that's not necessary. In short.
So.
Okay, thank you for the questions. Shall we thank all of you?